Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. This is driver comfort systems, operation, and testing. So it's kind of a catch-all of a lot of the things on a vehicle that are nice to have, but entirely not necessary to have, right? So things like we're going to talk about heated and ventilated seats. Really nice on a cold day, ventilated seats nice on a hot day, but definitely not necessary to drive the car down the road, right? So it's not a wheels or brakes or engine type of situation. It's a comfort situation. Same thing with heated steering wheel or noise canceling systems. So noise canceling systems are on those vehicles that, well, it's too noisy. There's too much road noise, or I don't want to hear the engine for some reason. So it actually generates a canceling waveform. It cancels that noise inside the cabin. We also have sound generation systems, which would be on the opposite end of that spectrum. So I can't hear the car going down the road. Say it's an EV or a hybrid vehicle. They have systems that generate a sound so pedestrians can hear them coming and not get hit by a car. That's probably a good thing. And then electronic motor mounts as well. So we have, those have been around for actually a little longer than you might think. And they help smooth out the engine vibrations. And they do it electronically. So these are all things, yes, they're not entirely necessary to drive a vehicle down the road, but they could break. And they can break on a vehicle that's definitely out of warranty. So where are they going to go? They might go to your shop to get those things fixed. So good to know and understand a little bit more about how they operate and how you might go through with the scan tool and diagnose them as we go. So first off, heated seats. So a heated seat uses an electric heater element underneath the fabric. So you have the exterior shell, and then there's an element inside another piece of fabric. It's kind of another layer underneath the seat. If you think something like a toaster, but flexible. So it's wires, and they run a current through there. It's not a huge current, it's a small current, but it's enough to make it heat up. And when it does heat up, it heats up the seat fabric, of course, and then it heats up your body through that transfer. Usually the seat and the back are separate, but sometimes they can be sewn together in one piece. So if the back goes out, you have to replace the bottom as well. It could be, or maybe it's just one piece goes out and you can replace that. And now it used to just be in the front seats, maybe even just the driver's seat, but now it's available in any seating position in the vehicle. A lot of your newer vehicles is going to be a heater element in each seat, so it's just another thing to break. But it is a nice comfort feature. I know driving my daughter to school last winter, she commented, says, my vehicle only has heated front seats. And she said, oh, well, I wish they'd come up with heated rear seats. So, well, they do. We don't have one of those cars. So it can be found anywhere in the vehicle now. And probably the easiest way to diagnose to see whether or not that element is heating up properly is using thermal imaging. So if you have a thermal imager, you can take a look and see on the left-hand side, that one's just kind of you can't see the elements at all. It's just kind of one even temperature across the board here. And then over here, we can see where the heater element's working. We can see the element, how it's back and forth underneath the fabric there. You can actually see it because it's a little bit warmer in that spot where the element is. You can see, oh, is there a break in the element, or is it just not working at all? That way you can see, okay, do I need a fuse? Do I need an element? Is it something in the harness? Whatever it happens to be. It's a good place to start because you can get a visual on that seat and see, well, is it operating properly or is it not operating properly? Other side of the coin, we have our ventilated seats. So instead of heating you up, it cools you off. Uses fans to push or pull air through the perforated seat back. So we can see we got the seat back there. Sometimes it's on the bottom part as well. And it uses like an electric fan, kind of like a computer fan in a way, to generate through ducts. And it just kind of cools you off on the back. Now, as I was researching, the seat manufacturers have said that it is difficult to make a comfortable seat that also is chilled without a fan. So it doesn't have a chilling element, but it does remove the heat from your body, removes the moisture from the air, so to say. So that's what cools you off. So we have a fan in here, and it has some ducting, and it pushes out the back of the seat. Now, in this case, this is a real fancy seat because we got a heater element there too, and it looks like by that arrow that we could have heated or cooled air being blown through there. So it blows it through the heater element, and that warms it up. Really hard to get a chiller element, like I said, and make it flexible enough to be a comfortable seat. So what they're talking. So useful though, helpful. Also in this one, it looks like we have a lumbar adjustment as well. We got some of these rollers here, and then we also have an adjustment there. It's like a string or a rope, kind of pulls it up and down on an electric motor there, and kind of move it up and down and move it out, as it were, with the lumbar seats. So that's heated and cooled seats. Now we have heated steering wheels as well. So that works on the same principle, the same type of element as in the seats. So we have an electric heater element that goes around the outside. And I'll tell you what, I was driving one last week. I had one for a rental, a vehicle that had it. And it helped out on those chilly early fall days that we had last week up in Chicago. So it's kind of nice to have a nice little toasty steering wheel there. Once again, do you need it to drive the car? No, but is it nice to have? Absolutely. And it could break down. Once again, easiest way to figure it out, anything that generates heat, you're going to want to use a thermal imaging device. In this case, we see that it's about 112 degrees at the warmest part of the steering wheels there. We can see the element going all the way around the outside. Over here is when it's just not on at all. It's like 92 degrees coming out the heater vent, maybe like 60, 70 degrees on the steering wheel. So it's not really any warmer than the surrounding area at all. Now we have noise cancellation. So noise cancellation, what that does is it plays audio using a microphone and the audio system. So it has microphones in the cabin, pulling in, listening to the ambient sounds, whatever they happen to be in the cabin. And then the audio system then generates a waveform of that sound out of phase with the rest of the vehicle. So it cancels it out. So if you know anything about sound waves, they look like a sine wave up and down. So if I put out a waveform that's opposite of that, so when it's down, it's up, and it's up, it's down, it cancels each other out. And then we get a much less of a waveform. You're still going to get some noise, but not nearly as much as you would without playing that cancellation. So in this case, we have the noise source. You see how it goes up, down, up, down, up, down. And this one goes down, up, down, up, down, up, like a mirror to this. So if you were to overlay them over each other, the peaks cancel each other out on either side. And then we get a fairly flat waveform, not a lot of noise going on. So if you've ever used noise canceling headphones, you listen to your iPod with it or whatever, Spotify, I don't know. Going for a walk, going for a run, going to the gym, whatever, have noise canceling headphones, or going on a plane. It does the same thing. So it has a microphone somewhere on the outside that takes the ambient noise in and then transmits through the earbuds a opposite phase of that noise, which cancels out any surrounding noise. And you still hear a little bit of it, might sound a little muffled, but it is, for by and large, just going to cancel out whatever the ambient noise is in the background. Now, the other side of that coin is our sound generation system. So that plays audio to alert pedestrians of a moving vehicle, usually found on hybrid vehicles and electric vehicles. It's commonly called acoustic vehicle alerting system, and it's mandated in Japan in 2010, Europe in 2014, and the U.S. in 2019. Now, the U.S. they signed it into mandate in 2014, but it took 5 years to go into effect. So it's fully effective in 2019. So anything 2020 and newer would have to have that. Must come on below 18.6 miles an hour or 30 kilometers an hour for those of you in metric. So anything above that, what they say is anything above that, you're going to hear the tires, you're going to hear the road noise. So you don't need that anymore above 30 kilometers. And manufacturers can use various tones or sounds. It can be varies by manufacturer, from manufacturer to manufacturer. In this case, we have one from a Nissan Leaf that we found on YouTube. So let's play that video and take a listen. To me, it sounds kind of like a jet engine. So VSP is vehicle sound for pedestrian. And to me, that kind of sounds like an alarm you might hear in a science fiction movie or something like that. So don't know why they couldn't have just used the traditional backing up sound that commercial vehicles use, but that's what they decided to use. So every manufacturer is a little bit different. I saw an ad for Kia where you can actually change the sound. You can change the cabin sound as well. So you can make it sound like different types of things, different types of engines and so on and so forth. So kind of interesting. Once again, don't really need it. I mean, the external noise generation, it's the law, so you kind of have to have it. But there are functional tests for it. There's different things that we can do to look through it and fix it, because it's going to break at some point. Sound generation system on the Leaf. So this is the bumper right there, front bumper itself. And then we have the couple brackets, and then we have these speakers that mount underneath the bumper. And that is what generates the sound out to the pedestrians. Now we come to active motor mounts. So these are vacuum controlled or electronically operated. There's a couple different ways they do that. And it's used to reduce NVH from the engine. So noise, vibration, and harshness from the engine. So if we have any sort of weird, maybe a little bit of a stumble or something like that, this will cancel it out to a point. So we need to be able to deactivate these in order to check something that might be not quite running right, but it's enough to cancel it out with that. Then it's really hard to diagnose. So we actually have functional tests that we'll show you in a minute. You can go and you can turn them off. That way it'll help you diagnose problems. Also, they can have problems themselves internally. So here's an older style. This is a vacuum operated one. So we got a vacuum switching valve here, got a vacuum tank there. And the ECM controls that vacuum switching valve, which can vary the amount of vacuum going to the engine mounting insulator. So that is the engine mount right there. And depending on how much or how little, it'll become softer or more firm. Just depends on how much vacuum is left there. Went from that up to electronically controlled active mounts. So it takes a bunch of signals into the PCM. So it needs to know crank signal and top dead center and so on. And then it sends it to this, and it sends opens and closes this plunger, or pushes the plunger out and in based on how it needs to react to the vehicle. So you see we have this plunger right there, and it pushes up on this diaphragm, which pushes up on the liquid. The liquid, you can't compress liquid, so it either gets firmer or less firm, depending on how far it's pushed up. And then, of course, we have the regular rubber for the mount up there. And that is an electromagnet down here, runs on pulse width modulation. So we have the actuator down here. We can see the coil kind of wraps around it right there. And then it would push this plunger up and down, and it actuates this diaphragm. Now, one problem I have heard with these is they leak. So when they do leak, fluid's going to come out, and it's not going to be able to do its job because the fluid's just going to leak right out. So it's not able to stiffen up or loosen up, as it were, with that. So here's a little bit closer look at that. We got a little plunger actuator there, pushes up on the diaphragm, which pushes up on the liquid, depending on how stiff they need it. And there's the external shot of that. And then here's how Audis do it. So this is a little bit different take on that. Still use electromagnetism. But in this case, it looks to me like they designed it kind of like a speaker. So if you've ever seen a speaker, a loudspeaker, it's going to have a magnet around the inside, this magnet on the outside, kind of groove cut into it. And then it has a circle of a coil of wire. When it activates it and sends electricity through that wire, it's going to ride up and down on the magnetic fields there, and it's going to push on this diaphragm. That diaphragm, kind of like a speaker, so maybe it's rubber probably, but the little diaphragm is going to move up and down. It's going to oscillate against the engine movement, which will allow it to dampen the engines. We also have fluid in there, and it's going to push up on the fluid. Very similar idea to what we had going on with that other Honda mount we were looking at. But this is just how Audi decides. Like I said, it looks a lot like a speaker. And I'm pretty sure it works on the same principle as the speaker. So that's kind of interesting. A little different way to do. All right. So this particular presentation isn't terribly slide heavy. It's more on the tool heavy because we got a lot of different systems we're going to walk through and talk about what we can see on the tool. The other nice thing about this one is I get asked all the time, well, you do the class on the Zeus all the time, or you do the guided component test. What about the scanner stuff? What if I don't have guided component tests? Perfect, because all the stuff we're going to talk about in this case is stuff you can do with the scanner. Won't go into the guided component test at all. You could go in and guided component test and test it. You can test for voltage and ground and such, but we don't have any specific guided component tests for these particular items. So in this case, in this class, we are going to be going into a lot of scanner stuff, but I am going to go into shop P2. So let's look at this Honda Pilot first. We're going to look at the active motor mode. Go into our repair information and see what we can see. Okay, so there's my landing page for the Pilot. I'm just going to type in active and should get an engine mount right there. Okay. So first things first, let's look at TSB. So it looks like there's at least one TSB on this, and there is just one. So it says the title is Rear Engine Mount Chirps. Interesting. Affects pilots and ridge lines. The symptom is you hear a chirping in the cabin with the engine running, the transmission and drive, and the engine at operating temperature. Possible cause is an issue with the rear engine mount that can cause internal components to wear prematurely. This may cause a chirping once the engine warms up. I'm going to do the diagnosis and based on results, replace the rear engine mount. There's some parts, there's some warranty stuff. Here's how we diagnose it. I'm going to start the engine, make sure it warms up to operating temperature. We're going to put the transmission in drive and apply the parking brake. Replace a stethoscope or a long, thin screwdriver on the airbag mounting bolt and listen for a chirp. Apparently, I can hear the motor mount chirp through the airbag. So it must just be how it's mounted on the steering shaft. If you hear the chirp from the rear engine mount, go to step 3. If you hear a chirp coming from a high pressure fuel pump, refer to this bulletin. If you hear a chirp coming from the timing belt area, refer to this bulletin. If you do not hear a chirp, this doesn't apply. So apparently there's quite a few things that can make chirpy noises on the vehicle. One of them is the engine mount. So in order to diagnose this, is going to tell you one way to do it. I'm going to tell you a different way that might be a little bit easier. You're going to put the vehicle on the lift. You're going to remove the engine undercover. And then you're going to unplug the connector. And then listen for a chirp. If it doesn't chirp when you unplug it, if the chirp is gone, go to the repair procedure, which is repair the mount. If you still hear the chirp, that's not what it is. Easy enough. So if I unplug it and it stops chirping, then that was the problem. I would also imagine you could probably do a functional test to turn it off, which we do have inside of the scanner. So that's an interesting one. Next thing, let's look at wiring diagram. So wiring diagrams here drops us on page 2 because the active control engine mount relay is right there. So we'll just open this up. And we can see the relay is right there. Go across. And we'll see there's my mounts. The wires are highlighted right. So we can zoom in on that and we can see not a lot going on there. The control unit has power and ground and also some data lines. And then it has 2 wires that go to each of the mounts. So it's just a on-off pulse width modulated control signal. You can see it just got a coil right there. So it just goes in and out, power and ground or positive and negative, and move it up and down. So not a lot going on there. You can probably do a pulse width test on it. Check for power, check for ground, check for continuity. That's about it. Now let's see how much they are. Let's go to the parts and labor. See how long it takes to change them too. So if we go in here, front mount 2.8 hours, rear mount 1 hour. And then we see front and rear right there, 378 and 387, depending on whether it's front or rear on the mounts there. So those are the electronically controlled mounts. And that is list price from the manufacturer. You probably find aftermarket ones available for less, I would imagine. But in that case, that's what retail price is from the manufacturers. About 3-4 hours to replace them both, and like $800. Let's take a look at scanner functions we can do on this. So with this, we're going to go down to steering and chassis, and then we have active control mounts right there. Simulation mode. So we see we got codes, data, freeze frame, and functional tests. By going to functional test, we can do a reset of the system. We can do a test. We can turn the front solenoid on or off. We can turn the front and rear together on and off, or just the rear on and off. So if I'm trying to diagnose like a little stumble or a little hiccup that it might be masking, I can turn them both off, and then we can see how the engine runs after that fact. So it's just a simple on off. You turn it on, you turn it off. Data. We go in here, we can see it does need to know engine speed because it needs to be able to cancel out the engine, any vibration, if any vehicle speed, and then supply voltages, active engine cylinder. Oh yeah, the one thing I didn't mention about using these mounts is especially Honda on these pilots, they use them for when they have the cylinder canceling. So they can go all the way down to 3 cylinders on this V6. So when it does go down to 3 cylinders, it doesn't run so, pretty rough. So it uses those mounts to counteract that and make it so it's not as rough of a ride when it's down to 3 cylinders. And then it, of course, gives you the current flow. So not a ton of data, but it's enough to give me what I need to do. All right, so that is active mounts. Next one, let's look at a fancy seat. We're going to go into a 2019 BMW 5 Series. And this has got a fancy seat. All right, so you need to go down to, there we go. So driver seat module, let's do that. Okay, codes, data, functional tests. We want a functional test. We have actuator tests. And we have 1, 2, 3, 4, 5, 20 different actuator tests on this particular seat. Like I said, it's pretty fancy. We got backrest, angle back and forward, backrest upper back and forward, adjust the backrest width in and out, head restraint up and down, forward back adjustment, forward or back, seat angle down and up, seat depth adjustment back and forwards, seat height down and up, seat heating interval stage 1, 2, and 3, and then resetting the control unit itself. So a lot of different functions on there. So if I needed to check and make sure that it was working, like, hey, the seat heater may or may not be working. Is it the switch? What is it? So I can click on that and it'll turn it on or off. Simple enough, but it is good to have. Good to have. We got anything else on this? Oops, went too far. We got a bunch of ADAS, amplifier, roof functions, automatic luggage compartment. There we go. Let's see, front headlights, high beam assistant, night vision. Got a lot of stuff on this vehicle. Electromechanical power steering, virtual integration system, lots of different things. Very interesting. Next one, we'll do the Nissan Leaf with the vehicle sound for pedestrians. So that is in with the electric vehicle stuff. So hybrid and electric vehicle. And we have vehicle sound for pedestrians. Click on that. Codes, data, functional tests. Functional tests are going to be special functions. It's going to be sound pressure level change. So if it's not loud enough for you, this noise, we can do the default, which is just how it is from the factory, plus 1 dB, 2 dB, or 3 dB, so that's decibels. So plus 3 dB would be fairly noticeable. Plus 1 dB is probably not all that noticeable, honestly, but it just makes it a little bit louder if you drive in an area that happens to have a lot of loud noise in the background or whatever. It's going to make it a little bit louder for you. No, researching this, reading articles, people wanted to figure out ways to turn them off, but can't do that with this tool. Can't do it with the factory tool. Actuator tests. So we can turn the speaker on and off, and then we can have, there's an indicator that you can actually turn it off with a switch on a ignition cycle basis. So there's an indicator light for that to make sure that one. As far as data stream goes, so startup sounds, status and settings, off switch, reverse buzzer status, vehicle speed, engine RPM. It needs to know all those things in order for it to know when to turn it on and turn it off. So it needs to know speed, and engine status, and all that. So, good amount of data, good for that. Okay. And that's the Nissan. And we got this Grand Cherokee here, 2018 Jeep Grand Cherokee has that active noise canceling sound system in there. So let's take a look at that. What can we see? Got to do secure gateway on this, even though it's fake. Fake vehicle, still got to do it. All right. So we're going to come down here, and that is should be in with the AV right there. So in with the audio visual because it's part of the radio. Active noise cancellation right there. We have codes, data, system tests, and miscellaneous functions. So miscellaneous functions is going to just give me ECU information. System tests, we got a tone test, an output short test, a microphone tone test, and a microphone output short test. So we have a bunch of different tests we can do that'll send different tones and such through the vehicle to make sure everything's working. Data, I found this interesting. Like, what does it need to know? So is it on? Is it off? What's the battery voltage? Is the door open? Are any of the doors open? Because that'll change the amount of wind noise or amount of noise in the vehicle. How about the window position too? Drivers and passengers window position percentage. So if it's open, it's going to change the sound, the noise profile inside the vehicle. So it needs to know, oh, is it open or not? Or are any of the doors ajar? So it's kind of interesting. Didn't really think about that, but that is definitely something that the computer needs to know for sure. Let's look in shop key on this too. I don't know. Let's call it that. Active noise cancellation. There we go. The information. Component operation tells us how it works. The active noise cancellation module is a standalone module on some SRT vehicles equipped with the Alpine audio system. The module is located behind the right rear quarter trim panel. On certain models equipped with the Harman Kardon audio system, module is integral to the audio amplifier located behind the left quarter trim panel. Also includes 4 microphones located in the headliner. These microphones are serviced separately from the headliner. So if you replace the headliner, you don't need to replace them. Performs the creation of signals appropriate to cancel engine odor related vehicle noises from the engine. It creates the signals in proportion to the engine RPM, plus any other needed input. The active noise cancellation module obtains the engine RPM from the vehicle powertrain control module. Signals that the active noise cancellation module creates includes at least 4 simultaneous signals equivalent to sine wave frequencies in designated ratios, tracking the engine RPM to cancel engine odor-related noises, plus the other output signals that can enhance the cancellation effect. To maintain the effectiveness of the noise cancellation over a full range of vehicle operating conditions and seating locations, the active noise cancellation module has 4 outputs and process signals from 4 microphone assemblies located in the headliner. So imagine they're probably at 4 seating positions and then 1 of each of the speakers. Active noise cancellation module supports mixing the 4 ANC signals into any output channel at a point after all the signal processing is required. The module operates on vehicle battery power and is a state of operation controlled by CAN bus. In addition to performing active noise cancellation, the ANC module supplies power to the loudspeaker. Different variants there, hardwired circuits. However, conventional diagnostic methods will not prove conclusive in the diagnosis of the active noise cancellation module or the electronic control and communication features of the module. The most reliable, efficient, and accurate means to diagnose the ANC module or the electronic control and communication features related to the module requires the use of a diagnostic scan tool. So you need to go in there and check it out. So interesting information there when it comes to the active noise cancellation. All right, let's go in here and stop that vehicle. Vehicle history, and the last one. This one was I just thought was really interesting. So there is a feature on Mercedes-Benz on a convertible. It's called an air scarf, and it does pretty much what it says on the tin. So it is a air scarf. So if I'm driving around and it's a brisk autumn evening like it is up here today, I can go in and it will blow warm air over my neck and keep me warm. So we have a air scarf here. So we have codes, data, and functional tests. So special functions on here. We can tell the last cause of automatic shut off, but automatically shuts off. Actuator tests. What that's going to do is it's going to just run the whole system for 5 seconds. Going to turn the blowers on, turn the heaters on. It's just a start stop in that case. But yeah, it's a fan and a heater element. We go into data. You can see the function test data. So how is my function test functioning? And if we go to the other data group, we can see the outside temperature, temperature of the control unit, vehicle interior temperature, and then it knows what stage of blower it's on. I just thought that was kind of wild. But hey, it's a Mercedes, so I guess nothing's really kind of crazy for that, right? Mercedes got some really interesting technology. So we'll see what Shopkey has to say about that too. So I know you have to look through the keyword search. All right. So it's located behind the rear seat on the partition wall of the trunk. The air scarf control unit communicates over the heater bus, LIN bus, to the rear signal acquisition module. Let's see, we have left and right fan motors, left and right heating elements. And then if we go up here, it's going to tell me how it works. It's in all caps, so it's easy to find. Let's see. Climate control unit sends the interior temperature over a CAN, rear signal acquisition module control unit, and heater LIN to the air scarf control unit. If a valid interior temperature value is not available, the outside temperature is evaluated as a substitute value. The air scarf function allows the neck area of the driver or the front passenger to be ventilated with warm air at 3 heating levels. The warm air comes out of an opening below the head restraint. The air scarf control unit actuates the air scarf function depending on the following variables. What's my selected heating level? What's the outside temperature? What's the vehicle speed? And is my top open or closed? And then we have 3 buttons. They'll do 100%, 65%, 35%, and off. And then we have the motors and the heaters. They're switched on after a 7-second delay. This prevents any cold air from flowing out immediately after activating the function. Secure startup of the fan motors. These are actuated independently of the selected heating level for half a second with maximum control voltage. During switch off, the fan motors run on the lowest stage for 5 seconds to protect the heating elements from overheating. So it blows air over it to cool it off. And then it just needs to know, how warm is it outside? How warm is it inside? And we don't really need to get terribly deep into this development, but I just thought that was really interesting that there was such a thing on a convertible. So I guess it'd be really nice on a night like tonight where it's going to be like in the 40s at my house, go cruising in with my top down for some reason and have that nice warm air scarf blowing over. And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, oh, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/Snap-on Diagnostics UK. With that, time for questions. If you have any questions, just feel free. Once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully, we'll see you next week. Hopefully, you can watch and see you on any of our other videos. Have a good week, have a good night, and take care.